Class 9 Science Measurement Unit 1. Whenever we purchase daily items like rice, pulses, meat, milk, vegetables, fruits, etc. from the market, shopkeepers they do not give us the things without measuring. They give us the things only by measuring. Like for example, the mass of rice is measured by using beam balance. The volume of milk is measured in liter, and the length of clothes are measured in meter. So in this way, the shopkeepers they measure the things and they sell it. So to measure, they compare the unknown physical quantities with the known standard quantities. So the process of comparing unknown physical quantities with non standard quantities is known as measurement. Measurement has two parts, that is the numerical part and the unit. Like for example, if I say 5, that is the numerical part. The 5 denotes only the number. If I say 5 kg, it denotes the mass. If I say 5 meter, it denotes the length. If I say 5 second, it denotes the time. In this way, the numerical and the unit are used to measure are the two parts of measurement. Now, what is physical quantities? Those quantities which can be measured, the measurable quantities like length, mass, time, volume, temperature, they are the physical quantities. The physical quantities are classified into two types. They are fundamental physical quantities and derived physical quantities. Fundamental physical quantities are those which are basic and independent. They do not depend on any other physical quantities, that they are known as fundamental physical quantities. Like for example, length, mass, time, current, temperature, they are fundamental physical quantities. They do not depend on any other physical quantities. They are known as fundamental physical quantities. Similarly, derived physical quantities are those quantities which derive from fundamental physical quantities or that depend on fundamental physical quantities. For example, like area, volume, density, work, etc. are fundamental physical quantities. Like area, it is calculated by calculating the length. Length is fundamental physical quantity. Area is derived physical quantity. Units. Now there are units. Just now I have told before, the measurement has two parts, that is the numerical part and the units. Numerical part, it denotes the number, and the units are used to measure physical quantities. They are the reference standard. By using them, we come to know what kind of physical quantity is that. The units are always used with numbers. Like for example, if I say 5 kg, the kg, it is the unit of mass. 5 second, it is second, that is the unit of time. In this way, by using the units, it is used to measure physical quantities. And there are two types of units. They are fundamental units and derived units. First of all, what is fundamental units? Those units which are used to measure fundamental physical quantities are called fundamental units. For example, like length, it is fundamental unit. fundamental quantity, and it is measured in meter. Meter is fundamental unit. Mass, it is fundamental physical quantity. Kilogram is fundamental unit. Always fundamental units are used to measure the fundamental physical quantities. And there are 7 fundamental physical quantities and units, derived units. Derived units are those which are derived from physical quantities, derived from the fundamental physical quantities. They are depend on fundamental physical quantities. Like for example, Newton, Pascal, square meter, cubic meter, they are some examples of the derived unit. Likewise, how they are derived, like for example, area. We know the formula of area is length into breadth, and its units, derived units are like length is measured in meter, breadth is also measured in meter. Meter into meter, it comes to be square meter. Similarly, for volume, length into breadth into height, and length, breadth and height are measured in meter. That is meter into meter into meter, it comes to be cubic meter. So this cubic meter, square meter, that they are the derived units, and so on for other examples. Now, how the power is derived unit, or the unit of power is derived unit? We know that power is the rate of doing work. From the definition, we can get the formula: power is equal to work done by time taken, or P equals to F into D by T, where W is equal to F into D. Instead of work done, we use F into D. Again, let's break the formula of force, that is M into A. Instead of F, we use M into A into D divided by T. Now, by placing the related units, the unit of power is watt, denoted by capital W, and unit of mass is kg, kilogram, into unit of acceleration is meter per square second, into unit of displacement is meter, into the unit of time is reciprocal, that's why 1 by s, second, 1 by second. Now let's multiply them, or W equals to kg into square meter into 1 by s. When we multiply once more, or W equals to kg square meter by cubic second. And according to the laws of indices, the power in the denominator, that when it comes to be numerator, it becomes minus. That's why there comes to be W equals to kg square meter per cubic second, that is minus power 3. Thus, the unit of power, that is watt, depends upon the fundamental units like kg, meter and second. That's why it is derived unit. Pascal is derived unit. Why? It is because we know Pascal, it is the unit of pressure, and we know that pressure is the force applied per unit area. So from the definition, P equals to F by A. Again, by using the formula of force, P is equal to M into A by capital A, it denotes the area. By placing the related units, pressure, its unit is Pascal, mass kg, acceleration meter per square second, and area, it's reciprocal, and it is meter per square second. So Pascal, PA, is equal to kg per meter per square second. So the unit Pascal depends on fundamental units like kg, meter and second. That's why it is derived unit. SI system. In 1960 AD, an international conference held in France decided to use particular units to make similarities in measurement all over the world. And these units are called System International D unit, or in short form it is SI unit. And this system of measurement introduced by Paris Conference that brings uniformity in measurement all over the world, that it is known as SI system. And the SI units and the fundamental units and derived units are formed by this Paris Conference. There are mainly 7 fundamental units we have learned before also, that is mass, length, time, current, temperature, amount of substance, and the luminous intensity. These are the 7 fundamental units, and these are obtained from the Paris Conference. Now, importance of units. Units, it helps to bring uniformity in measurement all over the world as they use the same units, and it is convenient to use. It eases the global trade, business, and exchange of goods. These are the some importance of units. Now, what is 1 standard kilogram? 1 standard kilogram is defined as the mass of platinum iridium cylinder kept in International Bureau of Weights and Measurement in France, Paris, at 0 degrees Celsius and 1 atmospheric pressure, that it is known as 1 standard kilogram. That is the weight of platinum iridium alloy cylinder which is kept in France, in Paris, at standard pressure and temperature. What is 1 standard meter? 1 standard meter can be defined as the distance between 2 fine parallel lines of gold which are marked on platinum iridium rod kept at 0 degrees Celsius and at 1 atmospheric pressure in International Bureau in France, Paris. It is known as 1 standard meter, the distance between the 2 fine parallel lines of gold that is marked or engraved on the platinum iridium alloy. It is known as 1 standard meter.